Today I am going to teach about the unit 4 part A question answer. The first question: what are optical materials? What are optical materials? Give its types. Question: what are optical materials? Give its types. So the answer is the material which are sensitive to light. Material which are sensitive to light. Material which are sensitive to light is known as optical material. The different types of optical materials are: the first one is transparent material, transparent. The second one is translucent. The third one is opaque material. Once again, three types are there. The first one is transparent material. The second one is translucent material. The third one is opaque material. So that is the answer of first question. And second one is define carrier generation and recombination. Or sometimes they ask, what is carrier generation and recombination? First, see about the carrier generation. It's a process of carrier generation is a process of generating electron hole pair. Carrier generation is the process of generating electron and hole pair. This generation may be possible by the way of light intensity, or the same may be produces with the help of the external electric field. Two way the carrier generation is possible, with the help of external electric field or with the help of the light intensity. So the materials are the devices are photodiode and so on. So define carrier generation. It is a process of generating electron hole pair. Then recombination. Recombination is a process of combine of these electron hole pair already produced. The combination of electron hole that pair that already produced is to recombine. That is recombination. Now we go to the third question. What is an optoelectronic device? Optoelectronic device. Optoelectronic device nothing but a device which convert light energy into electrical energy. Light energy into electrical energy and vice versa. At the same time, some devices which may convert electrical energy into corresponding light energy, that also under the category of optoelectronic device. Optoelectronic device is a device which convert a light energy into electrical energy and vice versa. So many devices we have, that is photodiode, solar cell, then LED, and so many devices are there. Now we move to the next question. What is the principle of semiconductor laser? Question is, what is the principle of semiconductor laser? Very simple one. The principle of semiconductor laser is a PN junction diode. A PN junction diode is provided by, suppose this is a PN junction diode is provided by, that is forward bias. This is forward bias. PN junction diode is provided, supplied by a forward bias. Then automatically the electron hole pair will be created. Electron hole pair will be created. This pair creation and recombination process will be taken place. That means when this forward bias, after this forward bias happening, the majority charge carrier of hole that is available in p-type semiconductor enter to n region. The majority electron available in n-type semiconductor enter to p region, and the recombination will be taken place. As a result of recombination, initially one photon will be released. One photon will be released. This emitted or released photon further undergoes stimulation. Further undergoes the stimulation purpose. Stimulate further emission of light. That result a large amount of photon that will be released. That is a basic principle of semiconductor laser. Now we go to the next question. What is a solar cell? What is a solar cell? We already learned about this. Solar cell is a large area photodiode. Solar cell is a large area photodiode that convert light energy into electrical energy. Convert light energy into electrical energy. The next we move to the next question. Question number 6. What is OLED? OLED nothing but organic light emitting diode. Organic light emitting diode. Then a solid state. It is a solid state device. It is a solid state device made up of thin film of organic molecules. Solid state. It is a solid state device made up of thin film of organic molecules that produces light when a suitable application of electric field is given, or when a suitable electric field is provided, electric current is given. So once again, what is OLED? OLED means organic light emitting diode. It is a solid state device made up of thin film of organic molecules that produces light with a suitable application of electric current. Next, question number 7. What are the advantages of OLED? What are the advantages of OLED? The first advantage is it is very thin, extremely thin one, low cost, less power consumption, expense is also, that is low cost. So these are the advantage of OLED. The next, what is LED? LED nothing but light emitting diode. LED nothing but light emitting diode. What is LED? Give its principle. Sometimes they also principle. Give its principle. LED is a semiconductor PN junction diode. LED is a semiconductor PN junction diode which produces light when a suitable forward bias is provided. LED is a semiconductor PN junction diode. LED is that similar to already produced about a semiconductor laser. but a slight difference in semiconductor laser. The junction part which is covered by some glass in order to achieve the laser action, but here there is no glass. LED is a semiconductor PN junction diode which produces light when a forward bias is provided. Then what is the principle? The principle of LED is actually the principle of LED is very simple. Here also the recombination and the electron hole pair creation will be taken places. That is injection luminescence. That explained previously in the question. What is mean by injection luminescence? By the application of suitable that is intensity of light, the charge carriers are injected from p type to n type and n type to p type. Then recombination will be taken place. As a result of recombination, light will be come out. That is LED. Next, list the advantages of LED. There are so many advantages are there. LED, actually LED is very useful and very small size. Advantage, regarding advantage is small size, low cost, then low power consumption once again. So then less weight is also advantage of LED. Next we move to the 10th question. Why the shape of LED is made hemispherical? Why the shape of LED is hemispherical, like that? This form, actual form is hemispherical. Why this LED is, why the shape of LED is made hemispherical? The answer is, the shape of LED is hemispherical in order to minimize the reflection losses, like reflection losses. The shape of LED is hemispherical because of the eliminate, in order to avoid the losses, that is reflection losses. So these are the answer of first 10 question. Now we move to the 11. Now question number 11. How an LED can be converted into laser diode? Previous question itself explained what's the difference between diode and laser diode and LED. Now once again another one question is there. How an LED can be converted into laser diode? Actually LED means which produces normal light, different color light, possibilities of producing different color light. But diode, laser diode, that produces laser light which is monochromatic. So the emitted light from LED and also laser diode is entirely different. But the question is how an LED can be converted into laser diode. Very simple. When current intensity increases, the same LED where the current intensity is high, due to that that is population inversion is achieved. When current density is high, which automatically produces population inversion. What is the meaning of population inversion? Generally, population inversion nothing but the number of atoms available in excited state is greater than that of the number of atoms available in ground state. Similarly, here the excitation will be taken place. That means electron, everything move in the higher energy state. That is a population inversion. So population inversions taken place due to high current density. Then that produces population inversion, and the same time the opposite end of the LED is going to be polished. Suppose LED also made up of PN junction diode, actually P type and N type. If a simple P and N type semiconductor alone is there, then when an electric current is given, automatically the light will be come out from the junction, that is LED. By the way, we are getting large amount of electric current. Due to that, large transformation will be taken place, so that which achieve the population inversion. As a result of population inversion, that means more charge carrier transformation will be taken place. In addition of population inversion, here this junction, everything is coated by this polished surface, means automatically the first emitted photon will be reflected back and forth. That stimulate further emission of photon. As a result of that, large number of photon be released. That photon all reinforce with each other, that produces a laser. So we are able to convert LED into laser when current density is high. Okay, now we go to the next question. What is mean by optical data storage? What is mean by optical data storage? It is a storage device which store the data. Whenever we need, we are able to redrive it. It is a storage readable medium. That is optical and readable medium. It is and low power consumption. It becomes readable. That means data are going to be recorded and retrieved. By the way of this data storage system, we are able to record the data and retrieve the data with the help of optical, that means suitable light, most probably laser. Then list the various optical data storage technique. List the various optical data storage technique. What are the different data storage technique? You know, CD-ROM, compact disc, CD-ROM, DVD, and that is Blu-ray disc, magnetic, that is optical devices, holography. So CD-ROM, so many CD-ROM, everything we know, CD-ROM, DVD, and then Blu-ray devices and disc, Blu-ray disc, magnetic digital disc, and holography. These are the various that is optical data storage technique. Then next question, mention any 4 types of photodiode. The first one is PIN. What is mean by PIN? P type, intrinsic, N type. P type, intrinsic, N type. That is one diode. That is any 4 types of photodiode. One photodiode name is PIN. P type, intrinsic, N type photodiode. Then the second one is APD, avalanche pin photodiode. Avalanche pin photodiode. PIN, APD, Then Schottky diode. Schottky diode I explained in the previous chapter. Schottky diode. Then the fourth one is solar cell. So how many? What are the different types of four types of photodiode? The first one is PIN, P type intrinsic N type photodiode. Avalanche pin photodiode. Then Schottky diode. The last one is solar cell. These are the answer. The next discuss the absorption, emission and scattering of light in metal. Discuss the absorption, emission and scattering of light in metal. The same question I explained detail in the first long answer. Absorption, emission and scattering. Absorption, you know, which the metal which is going to absorb whatever the light is going to be fall on it. This is happen due to the excess electron that available in metal is going to be absorb the light photon which fall on it. Then emission as a result of the electron which is jump from the excited state, higher energy state to lower energy state by losing energy. As a result of that, emission will be taken place, some photon will be emitted. The scattering as a result of attenuation of this intensity of wave. The process by which the intensity of wave is attenuated as it travel through medium. Scattering is scattering is a process by which the intensity of the wave attenuated as it travel through the medium. Attenuated means losses, some losses. When it is travel through some medium, some losses will be taken place. That is due to scattering. This is a scattering. So next question is, why the sky appear blue in color? The very simple. The sky appear blue in color because of the Rayleigh scattering law. Rayleigh scattering law, which explains that the scattering of light is inversely proportional to wavelength, inversely proportional to fourth power of wavelength. According to the question is, why the sky appear blue in color? That explained by a scientist Rayleigh. The Rayleigh scattering. According to Rayleigh scattering, the scattering, the amount of light is going to be scattered is inversely proportional to fourth power of wavelength. Among the 7 color, the lowest wavelength is belong to blue and the corresponding region, blue, violet, indigo. So that color is going to be scattered very much compared the high wavelength. That means less wavelength, low wavelength light is going to be scattered very much comparing high wavelength. So in the low wavelength, the blue region is there. So the sky appear blue in color. Then next question number 17. What are the optical properties? What are the optical properties? The optical properties of materials are absorption, emission, scattering. Absorption, emission, scattering and also reflection. Absorption, emission, scattering and reflection. These are the optical properties of materials. The next, how laser is different from LED. How the laser is different from LED. Just we divide the two column. One is LED and another one is laser. Just differentiate this. LED. First we move to the LED. In case of LED, which required low current, laser, that is high current density. As a result of high current density, laser action will be taken place, already explained. Then in case of LED, the junction diode need not polished. The junction is not going, no need of polished junction in case of LED, but in case of laser diode, this junction should be polished in order to get the population inversion, or in order to get the laser action. Output in case of LED, output is very low, but in case of laser diode, output is high. Then LED, low intensity light, and in case of laser it is high intensity light. And also further, this LED automatically, the ordinary process as a normal process will be taken place. Mono, that is chromatic light will be come out in case of LED, but in laser diode where stimulated emission will be taken place. Stimulated emission will be taken place. So that all the difference of laser light and LED light. Laser light is a monochromatic, LED light is achromatic, that is other different also. Now we move to the 19th question. Question 19. Calculate the number of photon from green light of mercury. Wavelength is provided. That number of photon from green light of mercury required to do 1 joule of work. So the given data, wavelength is given in terms of Armstrong unit, that converted into meter, 4961 into 10 power minus 10 meter, and this is a Planck's constant, we know. Then this question, first you are going to find how much energy is produces for this wavelength light. That is going to be find out by using this relation E is equal to h nu, Planck's energy relation. Then E is equal to h into nu in frequency. The frequency is actually velocity by wavelength. Then as usual we know that value of h and value of c, these two are constant. Wavelength is given. Then just to simplify by multiplying help of calculator, you can get E is equal to 4.006 into 10 power minus 19 joule. This is the energy corresponds a green light of wavelength 4961 Armstrong unit. Now the question is, how many number of photon for that particular energy for that is light. The number of photon required to do 1 joule of work, that is very easy. Just divide that particular energy 1 by the reciprocal of the energy, which gives number of photon required to do 1 joule of work. That is 1 by this 19, the value is 2.496 into 10 power 18. This 19 minus 19 will come to the numerator, it is automatically plus. So the result is 2.496 into 10 power 18 per meter cube. It means per volume, per unit volume. This is a number of photon. The number of photon required is just take the reciprocal 1 by 4.006 into 10 power minus 19. That's all. Now we go to the another one problem, more or less same method, but slightly different question. Now 20th question, the last question. An LED emit green light of wavelength. Here is a more different wavelength is given. Find out the value of Eg. Eg nothing but gap energy, that is band gap energy in case of LED. Because LED is made up of P and N type semiconductor. P and N type semiconductor doped mean there is a band gap. What about the band gap? Band gap energy is there. What about the band gap energy in case of LED? So the question is wavelength is given and energy gap Eg is asking, that is Eg is equal to Hc by lambda. This formula I know. Then Hc by 1.6 into 10 power minus 19. This is 1.6 into 10 power minus 19 lambda. What is the need of this 1.6? 1.6 into 10 power minus 19 is nothing but the charge of electron. Why we use this charge of electron here? In order to change that energy in terms of electron volt. So here it change into electron volt. Hc by 1.6 into 10 power minus 19. In order to change the joule into electron volt, that should be divided by the charge of the electron. So that changed electron volt. Then Hc, value of H, value of C we know. H is equal to 6.6 into 10 power minus 34, that we will know. C is equal to 3 into 10 power 8, that value is given. Then Hc by 1.6 into 10 power minus 19. As a result of that, you can get this 12400. Then divided by lambda. Then lambda value is known. Then by dividing these two values, you can get answer, that is 2.25. The energy gap in case of LED, the energy gap in case of LED is 2.25 electron volt. So these type of, this lesson, unit number 4, more or less all the questions related, that is problems related to this. Sometimes we change into electron volt, or you can change in terms of joule, anyway. So very simple, we use this formula, Eg is equal to Hc by lambda. So from this we conclude the unit number 4. So from next video onwards we will see about 5th unit. So part A over, already part B question we thoroughly studied in the previous videos. We will see the next video. Thank you.